This is an introduction to the product and quotient rules for derivatives. If we're given two functions, f of x and g of x, that are being multiplied together, and we want to find their derivative, then, as long as the two functions, f of x and g of x, are differentiable at point x, then their derivative is given by the following: f prime of x times g of x plus f of x times g prime of x. This can be restated in the following form: the derivative of the first times the second plus the first times the derivative of the second. Example number 1. If we have two functions, in this case x cubed and the function 2x to the fifth plus 6x plus 9, then using our formula we can find the derivative of the first, which is 3x squared, multiply that by the second function, 2x to the fifth plus 6x plus 9, and then we can add that to the first function, which is x cubed, multiplied by the derivative of the second function, which is 10x to the fourth plus 6. Example number 2. In this example, our first equation is given as e to the x, and our second equation, g of x, is given as 3x squared plus 1/2 x to the fifth plus 17x. We can find their derivatives easily, knowing that the derivative of e to the x is simply e to the x, and the derivative of g of x is 6x plus 5/2 x to the fourth plus 17. Then, again using our formula for the product rule, we can simply plug these equations in, and we end up with e to the x times 3x squared plus 1/2 x to the fifth plus 17x plus e to the x times 6x plus 5/2 x to the fourth plus 17. The quotient rule. If we're given two functions, f of x and g of x, that are differentiable at point x, then the derivative of f over g at point x exists, given that g of x is not equal to 0. This means that the derivative of f of x over g of x is equal to the derivative of f of x times g of x minus f of x times the derivative of g of x all over g of x squared. This formula is very easy to remember if you can remember the following rhyme: low d high minus high d low, square the bottom, and away we go. This means that we're taking the bottom, multiplying it by the derivative of the top, and subtracting the top times the derivative of the bottom all over the bottom squared. Example number 1. If we're given the following functions, x squared plus 5x minus 6 over x cubed plus 7x squared minus 6x plus 2, then we can use our equation for the quotient rule and plug in the following values. We have the derivative of the top, which is 2x plus 5, multiplied by the bottom function, which is x cubed plus 7x squared minus 6x plus 2, and then we subtract the top function, which is x squared plus 5x minus 6, multiplied by the derivative of the bottom function, which is 3x squared plus 14x minus 6. And then we put all of that over the bottom function, which is x cubed plus 7x squared minus 6x plus 2 quantity squared. Our second example. In the second example, our first function f of x is given as x cubed plus x squared plus x plus 1. And then the derivative of that would be 3x squared plus 2x plus 1. Our second function, g of x, is given as being 2x squared plus 7x, and its derivative is 4x plus 7. Doing it this way, we can then immediately plug our functions into our quotient rule formula. And this gives us 3x squared plus 2x plus 1 times the quantity 2x squared plus 7x minus the quantity x cubed plus x squared plus x plus 1 times the quantity 4x plus 7. This is all over the quantity 2x squared plus 7x quantity squared. That was a basic introduction to the product and quotient rules for derivatives, and more examples can be found in section 3.3 of your Calculus 1 textbook.